the example on page 85 of your workbook. So we have to work out the size of angle P in triangle PQR. So we are looking for angle P. And what you will notice is when you are expected to work out an angle, they will give you at least two sides in the triangle, or they will give you enough information to be able to work out the angle that you need. In this case, once again, like we did when we worked out the lengths of the sides, we identify our hypotenuse. So the side opposite the 90 degree is the hypotenuse. So PQ is the hypotenuse. We are looking at angle P. So therefore QR would be the opposite side, and PR would be the adjacent side. You are given the ratio opposites over hypotenuse, and hopefully by now you're all shouting out that opposites over hypotenuse is sine of angle P. So therefore, I can say sine of angle P is equal to 9 over 12. So 9 over 12 being my ratio. And just as we used our calculator to work out angles before, we're going to do exactly the same thing. So therefore, angle P, we're going to put that 9 over 12 into our calculator, but we start with the shift button. We're looking for an angle, so we say shift sine of 9 over 12. And that will give us an answer of 48,6 degrees, correct to 1 decimal place. So guys, while we have now worked out the value of P, you will often be asked to solve the triangle. Now what that means is you need to find all of the unknown angles and all of the lengths in the triangle. So in this case, we've just worked out the value of angle P. So if I would like to work out the value of angle Q, what we can do is, using the fact that angles in a triangle equal to 180 degrees, angle Q would be equal to 180 degrees minus the sum of the two angles that we are given, which is the 90 degree and then the one that we just worked out, which is 48,6. So we will get 180 minus 90 plus 48,6. We can do that in our calculator. Plus 48,6. And that gives us an answer of 41,4 degrees, correct to 1 decimal place. So in solving the triangle, we find all the unknowns. We've got all the values of the angles. We've got two of the sides. We can now work out the other side, PR. The one way you can do it is using your trig ratios, but the other way, which is much quicker, is Pythagoras, and that's what we're going to do now. So remember what Pythagoras says: in a right angle triangle, the sum of the square of the two shortest sides is equal to the square on the hypotenuse. So therefore, if we're looking at triangle PQR and using Pythagoras, I can say that PQ squared is equal to PR squared plus QR squared. So the one we are looking for is PR, which is one of the shorter sides. So in order to find that side, I need to take away from the hypotenuse squared QR squared. So therefore, PR squared will be equal to 12 squared minus 9 squared. So that's 144 minus 81. And because we're looking for PR, we would obviously need to take the square root of that entire thing. So it's the square root of 144 minus 81. And that will give us an answer of 7,94, correct 2 decimal places. Okay, so that is how you would work out or solve the right angle triangle if they ask you to find all angles and all sides. We are now going to move on to the example on page 86. We have to find the size of alpha in the diagram that they gave us. And as you can see, the way it's set up, we have more than one triangle. In order to work out alpha, we have to have at least two sides in the triangle. Now we can see that we are given that angle S is 90 degrees, since PS is perpendicular to QR. They've also told us that QS has a length of 18,5 and that SR has a length of 16 centimeters. Now remember, we've done this before. Where you have a side that's connecting two triangles together, the first thing you need to do is to work out the connecting side. And this will then get you into the triangle that is useful to you. So that means we need to first work out the length of side PS. In triangle PQS, which is where we're going to work firstly, we're going to work from angle Q. We are given QS, and that's our adjacent side. The hypotenuse is PQ. And so therefore the one opposite angle 40 PS would be the opposite side. We are looking for PS and we are given QS. So that would be the ratio opposite over adjacent. So that would be referring to tan. So therefore we can say tan of 40 degrees is equal to PS, which is what we want, all over QS, which is 18,5. So therefore, to work out the value of PS, all I have to do is multiply both sides by 18,5. So therefore, PS would be equal to 18,5 times tan 40. We can put that into our calculator. So it's 18,5 times tan of 40 degrees. And that will give us an answer of 15,523,343. And as I said to you before, guys, we're not going to round up at this point because we're going to use this answer later on. So we're not going to round it off. We're going to keep that entire answer as it is. So it's 15,523, and so on and so on and so on. We've got all of those values in our calculator, and we're going to use them as they are in the calculator. Now that I have the value of PS, I'm going to move into triangle PSR. From angle R, I am given the adjacent side, SR. Since PS is perpendicular to QR, that means both of these angles would be 90 degrees. The side opposite angle S, which is PR, would be the hypotenuse. And the side opposite alpha is the opposite side. So therefore, I've got the opposites. I'm looking for the adjacent. So once again, I'm using the ratio tan. So tan of alpha is going to be equal to the opposite side, which we've just worked out, over my adjacent side, which has a value of 16. So I've got tan alpha equaling PS over 16. In order to work out the value of tan alpha, I now need to write down my ratio. We know that PS, we kept it all the digits in the calculator. We're going to use them as they are. We're going to divide that by 16. And because we're looking for the angle, we're going to start with the shift button on the calculator. So that is the answer we are working with. So it's going to be shift tan of that answer divided by 16, close the bracket, and that gives us an answer of 44 degrees, and this is correct to the nearest degree. So therefore alpha is 44 degrees. And it's important here that we didn't round off, because if you do round off too early, you will have slight inaccuracies in your answer. So in this example, we saw how we can use the sides in a triangle to help us to work out the size of an angle.